Hi everyone, welcome back. Let's see another example with FCFS algorithm. Means I am trying to explain various different ways of using FCFS algorithm. Right now, this particular video shows when the arrival times are same, you have to favor the process which having the lower process ID. Okay, this is another kind of model. Let us try to solve it. They have given process ID, arrival times, burst time, starting time you have to calculate, completion time you have to calculate, turnaround time you have to calculate, burst time you have to calculate, average time, average waiting time you have to calculate, schedule length, throughput, efficiency and inefficiency or overhead we have to calculate, right? So in FCFS algorithm, the process are going to be allocated based on the first come first serve. If I draw the Gantt chart for it, let me say this is a CPU and starts at the 0th time. At 0th time, you have only one process available, that is P1, and as it is non-preemptive, the time required for to complete the task will be allocated directly, right? So by 2 will be completed. Next, by 2 nanoseconds, what are the processors available for us? P2, P3, P5. Okay, so these are three processes that are available for us by 2 nanoseconds. Among these three processes, which one give the first chance? P2 will get the first chance because it has arrived at 1 unit of time. So P2 burst time will be 3 units, so 3 units allocated, and it will complete by 5 units of time. By the time of 5 units of completion, what are the processes available for us now? One will be P3, another one will be P4, P5, P6 and P7. All the processes from P3 to P7 are available. But which one will get the first chance? The process which come at the earliest, right? But if you look here, out of these 2, 4, 2, 3, 5, which process come at the earliest? Two processes come at the earliest. One is P3 at 2 nanoseconds, another one is P5 at 2 nanoseconds. So when arrival times are same, what you have to do? You have to favor the process which is having the lower process ID. So lower process ID is what? P3. So it will be allocated to P3 guys. P3. What is the burst time of P3? 4 units. So that means 9. Then P5 will be allocated, whose burst time will be 1. It will be completed by 10 nanoseconds. So which means it has done. Then P6 will be allocated because it has arrived at 3 units of time, whose burst time will be 4. So 14. Next P4 will be allocated, whose burst time is 2, which means it will be completed by 16 units. And next at the last P7 will be allocated, will be completed by 18 units, as it also required 2 units of CPU. So this is the Gantt chart guys. Based on this Gantt chart, can we calculate or can we fill this particular table? Yes. What is starting time of P1? 0. Completion time will be 2. P2 will be 2 and 5. P3 will be 5 and 9. And P5 is 9 and 10. P5 will be 9 and 10. P6 will be 10 to 14. P4 will be 14 to 16. P7 will be 16 to 18. Right? Next, we'll calculate turnaround time. Turnaround time means completion time minus arrival time. What is completion time of P1? 2 nanoseconds. Arrival time is 0. Right? So turnaround time will be 2, 4, 7, 12, 8, 11. 11 how you got? 14 minus 3. And it will be 30. So if I calculate average turnaround time, that will be 2 plus 4 plus 7 plus 12 plus 8 plus 11 plus 13 by total 7 processes are there. So this is what you call it as average turnaround time. Similarly, can we calculate the burst time? Burst time is turnaround time minus burst time. Guys, here you have to calculate waiting time, not the burst time. It is because burst time will be given by in the question. So you have to calculate waiting time. So waiting time is turnaround time minus burst time. So what is turnaround time? This one minus burst time. So waiting time of P1 is 0, waiting time of P2 is 1, waiting time of P3 will be 3, waiting time of P4 is 10, waiting time of P5 will be 7, this also 7, and this will be the 11. It is because 13 is the turnaround time and burst time is 2. Average waiting time means 0 plus 1 plus 3 plus 10 plus 7 plus 7 plus 11 by 7. This is average waiting time. And schedule length is directly you can say maximum completion of time of all process minus minimum of arrival time of all process. That is 18 minus 0. You will get 18 is the scheduling length. Throughput is total number of processors 7 by 18 is the throughput. And efficiency, is there any wastage of CPU? No, which you can say that 18 by 18 units of time is perfectly utilized, 18 by 100%. Inefficiency is 0%, means the time for which I have used the CPU, there is no idle in the CPU utilization. Right? Hope you understood this video clearly. Thank you.